Good afternoon. Am I audible to you guys? Okay, so we will just continue from there. In last class, we will discuss about asymptotic notations. So can you tell me what are the three asymptotic notations? Anyone? So can you tell what are the asymptotic notations? Please. So can you answer?
Well, asymptotic notations represent complexity of an algorithm.
What are the three types?
Well, bubble sort in bubbles in bubble sort the algorithm is linear, so that is the best way. Sorry, ma'am.
Rule
Actually,
number one. Can you tell me what are the asymptotic notations? Number one. Please, are you there? Rule number 17. Rule number 17.
Ma'am,
Yes. What are the asymptotic notations? Three notations we discussed in last class.
specific notations.
Yes. See?
I didn't hear the question, ma'am.
What are the three asymptotic notations? Can you answer? Rule number 04, Minal Eka. Can you tell me what are the three asymptotic notations?
Ma'am, theta, omega, and big zero.
Big zero নহয়, big O.
Big O.
Big O to কিহৰ কাৰণে use? What is the time complexity? What is time complexity?
Ma'am, amount of time required to complete algorithm. Complete the algorithm.
Okay, so why do we need asymptotic notations? What are they? A big theta, omega, হেৰি পলালে এটা কি হয় কি কৰে
নাজানো।
Verse 11, roll number. Can you tell me?
Ma'am, average case complexity.
Which one is for average case?
Big omega. Big O.
Is it? For average.
Yes, ma'am. Yes, ma'am.
Big O provides what bound? Upper bound or lower bound?
Big O provides upper bound and lower bound, both.
Ah, Is it big O for both upper and lower bound?
Yes, ma'am. Big O is for both upper and lower bound.
No.
Because
Big
it's
O
the average
is-
case complexity.
Big O is for upper bound only, not lower bound or this one. The one you
Then
are
I
saying
think
is the
theta
theta.
was for average case. Yes, ma'am.
Yes,
That was for
theta
average
is
bound
the
and lower bound.
average case, right?
Yeah. And
Simple
big O
way
is the
to-
worst case.
Yeah, very simple way to remember. It's not like technical way. It's a non-technical way to remember them is there. See theta. You just remember the theta notation. It is very. It may be a dumb way to remember, but still it will work. Theta is like what? Just remember the notation. It's like a O with a bar in between, right?
Yes, ma'am.
So you can just remember it's like the middle ground. It provides for middle function is in the middle. That means average. Big O is like big zero, you can say. So it's like the worst case we can think about. So it will provide the worst case.
Okay, ma'am.
Okay. And omega is like it looks good or something like you can just think it. If you know the other two, obviously the omega one will be for the best case and it will provide the lower bound. It's a dumbest idea to remember something, but it will work for someone who doesn't want to go for like very technical thing. Okay. Okay, so asymptotic notations, it's like a mathematical notations, and with the help of asymptotic notations or these notations, we describe the running time of algorithm. So, running time of any algorithm, we mainly calculate in terms of three things: best case, worst case, and the average case. Means worst case means the maximum step your algorithm is going to take to finish the program. Average case is like the average amount of time it is going to take, and best case is like the minimum amount of time it can take. So mostly if you compare it with like sorting and searching, then it will be like how fast your program will find the target value. Okay. So there are three notations for three cases. Big O is for the worst case. The function will be down there. It will provide the upper bound. Okay. Then comes your omega best case and theta is for the average case. So now we will see why time complexity is so important. Okay. So see, there can be one problem and you can just provide multiple solution for this explain the graph and mathematical expression. This is nothing to understand. This is simple graph. Okay, see, when I say it, now what is your function here? Okay, function is in terms of n. Okay, function, your function, this fn denotes the time complexity. Okay, function defines the time complexity, and what is n? N is the input size. Okay, remember time complexity is always dependent on the input size. So Fn denotes the time complexity of your algorithm. Okay, and we need to calculate this function. Okay, so calculating this value of Fn function for smaller program is very easy. But for bigger program, if your program has many steps, then it is not that easy. Okay, so we compare different data structures, comparing their function value. Means if you use different data structure, the complexity will be different. Okay, in the graph part, this big O provides the upper bound. Upper bound means what? Suppose your function should take, just for example, 10 milliseconds. Okay, so with the help of big O, I'm just saying that your program maximum time limit is 10 milliseconds. Your program should finish executing the program within the 10 milliseconds only. So that means that's the upper bound. I'm giving the in worst condition, it should take 10 milliseconds. So it's the worst case. So if Fn is your time complexity, this is the bound I am giving. This is the upper limit or the upper limit for the time. Okay, this is Cgn is just any constant. Okay, for example, like 10. If I can represent 10 as like 5n, 4n, and 4. Gn is another function. Okay, if you can represent the time complexity in terms of fn function, that means you can represent another function with the gn function. Okay, just that constant term is added there. So with the help of big O, you are just giving the upper bound, setting the upper limit. Okay, so your curve, the time complexity curve will stay below this limited function. Okay, so n is the input size, n naught is any random input size, which should be less than your main input size. Suppose, for example, you have 20 items in your data structure. Okay, for 20 items, you need to sort 20 items. Okay, and I'm giving you time. It should take 5 minutes. Okay, so 5 minutes is the maximum running time for your program, and your n is 20 here, input size is 20. Then you can see if there is any other function, other constant, like out of 20, if you are able to sort at least 10 element within that limit or not. Okay. Sometimes it may be like it's going beyond the limit, and sometimes it will come lower limit. Okay, so basically you have to make sure that time complexity as a whole will stay below this upper limit. Okay, so C and not both are just constant, and you have to make sure this Fn function, that is time complexity bound, is from 0 to the upper limit function. Okay, for any n within this range. For any, even if it's 5, 10, whatever it is. If your input size is 20, within that limit, you should finish sorting the 20 elements within 5 minutes. Okay, so same goes for the omega only. That means I'm giving the lower bound. So I'm saying in best case, you should finish your program within 2 seconds. So 2 seconds is the minimum time limit. Your function can take more than that. It's fine. Okay, just giving the best means the fastest it can execute within 2 seconds. So 2 seconds will be your lower limit. If you can finish it within this limit, then it's fine. Okay, it can go above that, but the lower limit is the 2 seconds. So same thing here, your function will stay above the lower limit. CGN is the function for the lower limit. So here the curve will stay above. Okay, same way it's average. If you need to find the average one, that means you have to set the lower limit as well as the upper limit. So for the lower limit, we are defining the function as gn. The upper limit also gn, just the constant term will be different. It's for C1 and it's C2. So it's an average case. Your function should lie in between these two curves. Okay, so that's the average. Okay, so now see, it's a simple program. We need to find the square of a number. Okay, so this is the problem, and we can solve this problem in two ways. Earlier also I mentioned that we can solve the problem in many ways, and every programmer has their own way to run the program. Okay, or like to find summation of two numbers, three numbers, everyone can write their own program. As long as the logic is correct, it's fine. Okay, so here giving two examples, you need to find a square of a number. Okay, so first algorithm is that it's taking blind. It's using a for loop. Then it's just doing n equal to n plus n. Okay, so when the loop ends, n will hold the squares. Okay, so this is one algorithm. And second algorithm is just one linear algorithm. You are simply returning n into n. Okay. So two algorithms. One algorithm is taking 1, 2, 3, 3 lines, and second algorithm is taking single line. So which algorithm will be faster according to you? Which one will be faster? Algo 1 or Algo?
Algo 2.
Okay. Others? Algo 2. Why? Why? Because it's just taking single line. Okay. Now, how we will calculate the complexity? Okay. There are some instructions for that. Okay. See, count the number of elementary steps performed by any algorithm to finish execution. Okay. So whenever you write the program, just see the numbers. How many lines you have written to finish a program. So every line or each instruction will take single unit of time. Okay. Then apart from that, arithmetic and logic operation will take 1 unit of time, and assignment and return will take 1 unit of time. Logical operations, arithmetic operations, then elementary steps performed by the algorithm. Okay, then again assignment and return will take 1 unit of time. Okay, now what happens whenever we calculate time complexity, even if it is big or any, most of the time we are concerned about the worst case. The worst case complexity, the maximum time a program can take. Okay, so this simply removes all the constant factors so that running time can be estimated in relation to the n. N is what? N means number of input. It's always in terms of input. So for example, this is a simple piece of code, summation of AB and return A plus. So what will be the time for these two steps? Return will take one time, right? So return will take 1 unit of time. Again, arithmetic operations take 1 unit of time. So 1 plus 1, 2. Okay, it will take 2 unit of time and it's a constant time, right? So you can just represent it in terms of ON. Okay, so this is the previous one is the very simple one. There is just two operations. So return will take 1 unit of time and arithmetic operation A plus B will take 1 unit of time. So total time is the 2 unit of time. It's a constant time. Okay. Now it's another program. Here there are some assignments. Okay, you are assigning value to the inputs X. Then there are 3 operations: assignment, logical operation, increments, and there is always again arithmetic operation of plus and minus. So what will be the time complexity for this particular piece of code? Okay. Now see, for every line, there will be a particular cost. Okay. There is time involved and there will be some cost involved. Okay. For this one, I'm just writing it like 1, 2, 3. So there are mainly 4 lines, right? 4 significant lines. So in first line, what's happening? You are assigning the value 0 to X, right? That means it's just single value work. So it will not execute just one time, right? This line will work only one time. Only one time, right? You are assigning, initializing the value 0 to X. So cost is 1 and it will execute only one. Assignment operation will take 1 unit of time. So it's 1. Okay. Next comes number 2. So in number 2, what's happening in that? There are 3 operations inside your for. One is assignment, right? You are assigning or initializing the value I equal to 0. Then you are again comparing the value of I to n. It's a logical operation. So it will take another one time. Then this I plus plus, again you are incrementing the value of I. That means there are 3 operations are involved. So each of these 3 operations will take 1 unit of time. Okay, so total cost will be 3. Okay, total cost will be 3. Now you see that the n is involved. You don't know how many times it will be executed. For this one, you know this is a single line. It will be just executed once. Now we don't know n. What is the value of n? I didn't mention here. Simply written n, right? So since I don't know the input size, so I'll just write it like n, and it will this particular code will run up to n plus 1 times. Why n plus 1 times? Can anyone guess why it is n plus 1? So you can just check the floor. So how many times it will run? This particular piece of code, how many times it will check the condition? How many times it will check the condition. Are you getting n plus 1? Yes, n plus 1 times. Why see, n is 2. How many times it will compare? First, it will compare whether I value is 0 or not. 1 time. Next, it will check whether I value is 1 or not. Okay, 3 times. Then it's less than 2, right? So you have to write n plus 1. That means with plus 1 at least for 3 times it will run. Okay. So here it will compare the logics or the conditions for n plus 1 time. So time is 3 pi and total cost is 3 because 3 operations are in. Next you come to the line number 3. What's happening here? First thing is you are adding two values. So this will take 1 unit of time. Okay. Then this whatever result is there after adding these two numbers, you are assigning that value to x. So it will take another 1 unit of time. Right? So total cost will be 1 plus 1, 2. Okay. Now how many times this program will be executed? It will be executed n times because your condition up to 10. Yeah, n plus 1 because you are also checking the false value. Right? So for this one, if something is true, you will execute this code as long as it is less than 2. But the third time also you will check it, right? Whether it is true or not. When it is false, you will terminate the loop. So this inside portion will run 2 times, cost 2 times, but this condition checking you will do 3 times. So here in line number 2, the time is n plus 1 because you are also considering the false condition. But in this case, this line will be executed only when it is true. So time will be m. Okay. Now comes to the fourth. Fourth one is just returning one value. So cost is 1 or time is also 1. So now we need to find the total complexity. What will be the total complexity? The total time. It will be cost into time. Cost into time. Okay. So for first line, it's 1 into 1. 1. Next, for line number 2, 3 into n plus 1, 3 into n plus 1. Next, line number 3, 3 into n twice n, and last 1 into 1, 1. Okay. Now it's just simple addition. Now what you are doing, it will be twice n, then 3, here twice n plus 2. So 3n plus twice n equal to 5n, then 1 plus 3, 4 plus 1, 5. So total time is 5n plus 5. Okay. Since 5 are constant, as I already mentioned, if there is a constant term, it is going to simply ignore it. Okay. You can replace it. It's not only 5, it can be any value. Okay. It can be 6, 10, any value, doesn't matter. All we care about is the n. N is the input size. So you can represent this equation as C1n. C1 is for this constant and C2 is for this part is constant. So total is C1 into C2. Now again I mentioned it will simply ignore all constant. So since this C2 is a constant term, it is going to ignore this part. Okay. And here also you can ignore this part. So remaining term is just 5n. Okay. So again, same thing, the 5n, you can just 5. You can replace 5 with any value, 10, 20, 100, doesn't matter. All we care about is the n. So you can represent this term with Cn. Okay. So the time complexity of this piece of code is the O(n), which is the constant time. Is it clear? Just see once. Just look at this picture once. And let me know whether you are understanding this logic or not.
Ma'am, in the line number 3, you have said that it's n times. Is it n times because it's only considering the true values?
Yes. So if this line will be executed until and unless the condition is true. So it's just n times. But for the line number 2, we are also checking the false value, right? Because we need to terminate the loop also. So inside the loop, it will just run for n times. Here, there will be one extra unit of time because we are also checking the false times. Whether it is, the moment it will be like 3, it will terminate the loop. You can just check here also. The condition is 0, 1, 2. So for 0, it will be executed. When I equal to 1, it will be executed, right? 2 times. Now the moment, then again it will increment the counter, right? Then I will be 3. When I will be 3, this one won't be executed because it's not satisfying the condition. So this comparison part you are doing 3 times. 0, 1, 2. And here the line is executed only 2 times because the condition is only when I is less than 2. Means I is 1. That means 0. You are writing the value for I equal to 0 and I equal to 1.
Okay, ma'am.
What about others? This is very important to understand how you can calculate time complexity. Okay, this is the very generalized. I'll give you the tips the way you can just look at the program and you will be able to tell the complexity of an algorithm or program. I'll tell you the shortcuts, but you have to know the core part as well. How exactly it can be calculated. Okay. See here, the time complexity when I said 5n plus n, time complexity I simply said n and complexity is O(n). Okay. In some cases, you will see the figure will come like 5n squared plus 5n plus 5. Okay. For some program, maybe your time complexity will come like this: O(n) squared, 5n, 5. So in that case, what will be the complexity? Remember, we just think we are finding out big O. Big O provides the upper bound. Okay. So simply, if in any function you see the time complexity is coming like that, it will simply ignore this constant part. Okay, and it will also ignore this constant. It will only consider this part only, 5n squared. Why? Because see, suppose your input size is 10. Okay, if n is nothing but the input size, right? So this term anyway it will be ignored. So 5n squared plus 5n. You just check it separately. For 5n, 5 into 10, 50, right? Then 5n squared, it will be 5 into 10 into 10, 100. So 500. So on which term your algorithm timing is increasing exponentially? Okay. So if you increase the value of n, so it is increasing the time taken by the algorithm. But when you consider this n square, it is exponentially. It is like increasing exponentially. It's like twice like, right? The moment you are increasing the input value, if input is 1, then it will be 5 into 1 square 5. Then if n equal to 2, will be 2 into 2, 4 into 5, 20. So the running time of this algorithm is mainly depending on this 5n square term only. Therefore, we are simply going to ignore this part and time complexity will be simply 5n square. So if you again write in the same way, it will be cn square. Okay. So time complexity for this one will be O(n) square. Okay. Sometimes you will see in some places written like 10n square plus 5n plus 2n all. Okay. Then you have to find the time complexity. In that case, you can simply write it will be O(n) square because we are mainly concerned about the part which is increasing the time. Okay, here it's exponentially increasing. So we are only concerned about this part. We are going to ignore this part. Okay. Back to here again. So this is another way. Okay, write down this thing and think it as a homework. You need to find the time complexity for these two algorithms. 1, 2, 3. Write it down and let me know. Next class I will show. It's tomorrow. Oh wait, I can continue. So class. Just write it down, okay? This is your homework. At least try to find out the complexity. 1, 2, 3. Just simple step. Just write step. It can be repeated anytime. Have you noted down? So this is your homework. Tell me the complexity for this key thing tomorrow. Then I'll show you the shortcut to find out the complexity. Okay. Just looking at the program, you will be able to calculate the complexity. Okay. But before that, you have to know the core concept, how you can actually get. Just put it down the programs. Okay, see you tomorrow. Thank you. Tomorrow, just tell me the answers.